Hello my dear friends, myself Ashok Bagda from Dr. Subhash Technical Campus, and in today's lecture we are going to derive an equation of natural frequency for a simple pendulum. Okay, let us start. So this is we are going to determine an equation of natural frequency for a simple pendulum. So here a simple pendulum is given. So my dear friends, some m mass is attached at a string. The string is pivoted at the fixed point. Now if we displace the string, if mass in this way, then our pendulum is oscillating this way. So here let us consider a simple pendulum having mass m and length l is shown in figure. Now here the string, we consider the string having no mass. We consider massless string, and m, the bob having m as a mass. We can calculate the natural frequency by using following two methods. First one is the energy method and second one is the equilibrium method. Okay, so in this lecture we derive an equation by using these two methods, energy method and also by equilibrium method. Now my dear friends, we know that mass moment of inertia of simple pendulum IO. So this is the center of rotation, center of oscillation of simple pendulum O. So we can say that mass moment of inertia about xx. So IO is equal to ml square. This is a simple equation of mass moment of inertia of simple pendulum. Now as shown in figure, this is the neutral axis. If we displace this pendulum by excitation force, external excitation force, then it will oscillate in this way. But in this case we consider here there is no pivot friction and there is no air resistance. So we neglect two things. One is a pivot friction and second one is a air resistance. So my dear friends, this is initial condition and this is extreme right position of pendulum. So when our bobs reach at extreme right position, then there is a increment in height is small h. So from figure we can say that the small h we use here in this method, we use energy method. So small h is L, this is total height is L, minus this one is L cos theta, because this angle is theta. So theta is very small. Okay. So this is L minus L cos theta. So we obtain L in bracket 1 minus cos theta. So we know that the equation of kinetic energy. So simple kinetic energy is equal to 1/2 mv square. So m is mass and v is velocity. But here we consider a rotational kinetic energy because our pendulum is oscillating in this way. So rotational kinetic energy of mass is equal to 1/2 mass moment of inertia IO into theta dot square. So theta dot is the angular velocity. So this is a simple equation of kinetic energy, 1/2 IO into theta dot square. Similarly potential energy. So we know simple equation of potential energy, it is mgh, and in our case h is this is h. In our case h is equal to L in bracket L 1 minus cos theta. So mg in bracket L minus L cos theta. So we obtain mgl in bracket 1 minus cos theta. Now according to the law of conservation of energy, total energy remain constant. So total energy is equal to constant. So we can say that total energy here is equal to kinetic energy plus potential energy. So if we take a differentiation of this total energy, then we obtain 0 here. So d by dt in bracket kinetic energy plus potential energy is equal to 0. Now we put the equation. So d by dt here, kinetic energy is equal to 1/2 IO into theta dot square plus potential energy is equal to mgl into bracket 1 minus cos theta bracket complete and whole bracket complete is equal to 0. So if we differentiate, the 1 by 2 is constant, so 1 by 2, IO is also constant. Theta dot square, the differentiation of theta dot square is equal to 2 theta dot into theta double dot plus mgl is constant, the differentiation of 1 is 0 plus equation differentiation of minus cos theta. So cos theta is equal to minus sin theta, so minus minus plus here, sir. Minus minus plus, so sin theta into differentiation of theta is theta dot. So here we take a common, theta dot is common in these two equation. Again, if we simplify this equation, then we obtain io theta double dot plus mgl sin theta is equal to 0. Now here theta is very small, so we can replace sin theta is equal to theta. So io theta double dot plus mgl into theta. So we again rearrange this equation. Theta double dot is equal to mgl upon io into theta dot into theta is equal to 0. This is equation number 2. Now comparing equation 1 with theta double dot plus omega n square into theta. So this is the equation of simple harmonic motion. So we obtain omega n square is equal to mgl upon io. Now we put the value of io, it is a mass moment of inertia, it is ml square. So here ll cancel, so we finally obtain omega square is equal to g by l. So omega is equal to under root g by l. So frequency fn is equal to, so this is the equation of frequency omega upon 2 pi. So we obtain 1 upon 2 pi under root g by l in a hertz. And if we want to determine time period, then time period is equal to 2 pi upon omega. So 2 pi upon omega, so 2 pi under root g by l. So this is the equation of time period and natural frequency of simple pendulum by energy method. Now we see another method. It is the equilibrium method. Now D'Alembert principle, according to the D'Alembert principle, we know that the total forces or total forces acting on the system, the summation of total forces acting on the system should be 0, then our system may be in equilibrium. So we know that in our case there are two types of forces acting on a pendulum. So inertia torque and resisting torque. So this is a resisting torque and this is a torque because of mg. So by using this equation, summation of inertia torque plus external torque is equal to 0. Now we know that inertia torque is nothing but I into theta double dot. Inertia torque is IO into theta double dot. And external torque, here we can say that mg, this component, it is mg sin theta. This component is mg sin theta. So mg sin theta into L, this is a torque. So mg sin theta into L, this is a torque. This is active torque and this is a resisting torque. So again IO into theta double dot plus mg theta into L, because we replace sin theta as a theta because theta is very small. So again we obtain this equation, theta double dot plus mgl upon io into theta is equal to 0. This is the equation. Now again we compare this equation with this simple harmonic equation, theta double dots plus omega n square into theta is equal to 0. So we obtain omega n square is equal to mgl upon io. So mgl, finally we obtain omega square is equal to g by l. So we obtain omega n is equal to under root g by l. So fn is equal to omega upon 2 pi. So fn is equal to, we obtain 1 upon 2 pi under root g by l in hertz. And similarly, if we want to calculate time period, then time period is equal to 2 pi upon omega. So we obtain 2 pi under root l by g into second. Thank you.